Hi, welcome back. This is Nick Agriam. In this video lecture, I will be discussing sum and product of roots of quadratic equations. It is for grade 9, grade 9 in the Philippines. I think it is the best way to illustrate this first by giving you an example. For example, x squared minus 5x plus 6 is equal to 0. By factoring, I can factor this as negative 3 and negative 2, so that when I add them together, I will get the second term, or the middle term. That's why we have x minus 3 and then x minus 2 is equal to 0. We separate the factors, then we have x minus 3 is equal to 0, then our x sub 1 is equal to positive 3. The same is true with the second factor, and we have x sub 2 is equal to positive 2. If we add them together, then we will have x sub 1 plus x sub 2, then we will have 3 plus 2, then we will have 5. And if we multiply them together, x sub 1 multiplied by x sub 2 is equal to 3 times 2 is equal to 6. It will ring a bell. 5 you can see there, and 6 you can see there. Let's see if we can have some more examples. We will have this one. 4x squared plus 16x plus 15 is equal to 0. And then if we take the quadratic formula, then we have negative b, which is 16 divided by 2. We will 2 times a, 4. Then plus minus the square root of b, that is 16 squared, minus 4 times a, which is 4, and times 15. Then we have x is equal to, we have 16 divided by 16, negative 16 plus minus, we have 16 squared. What will be that? 16 squared is 256. 256 minus, we have 4 times 15 is 60, times 4 is 240, divided by 8. Then our x is negative 16, negative 16 plus minus square root of 16 divided by 8. And we have x is equal to negative 16 plus minus 4 divided by 8. So our x sub 1 now is negative 12 divided by 8. Negative 12 divided by 8, we have negative 1.5, and our x sub 2 will be negative 20 divided by 8. 20 divided by 8, then we have 2.5, negative 2.5. I am using the Swedish notation. 2.5. 1.5 and 2.5. Okay, and then when we add them, x sub 1 plus x sub 2 is equal to negative 1.5 plus negative 2.5. That will give us 4. and then x sub 2, x sub 1 multiplied by x sub 2 is equal to negative 1.5 multiplied by negative 2.5. Sorry, I will remove that. You will be confused. Multiplied by negative 2.5. And we have 1.5 multiplied by 2.5. Then it is 3.75. 3.75. That's positive. Okay, now that you have seen two examples, I will make the generalization of that, and then we will come back to these examples later and try to check if our generalization applies. Okay, for example, I have ax squared plus bx plus c is equal to 0. According to our equation, quadratic formula, we have negative b plus minus square root of b squared minus 4ac divided by 2a. So actually my first root is negative b plus minus square root of b squared minus 4ac and divided by 2a, and sorry for that, it is plus first. And my other root is negative b minus square root of b squared minus 4ac divided by 2a. So if we add that, if we add x sub 1 and x sub 2, then we have negative b plus minus square root of b squared minus 4ac divided by 2a plus negative b minus square root of b squared minus 4ac, where did I get that, divided by 2a. As you can see now, it's positive there. Sorry for that. As you can see now, we have the same numerator. That means we can add the denominator. We have the same denominator. Now we can add the numerator. Sorry. So this one will be 0. Then we have negative b. So x sub 1. This is x sub 1 plus x sub 2. So x sub 1 plus x sub 2 is always, according to this generalization, is negative 2b divided by 2a. That means negative b divided by a. So if we go back here now to our example, our product, our sum for x sub 1 plus x sub 2, it should be negative b divided by a. So if we take negative b, which is 16, divided by a, which is 4, then we have negative. Why I got negative? It should be negative 4. Negative 4 there. Negative 4. It's the same there. Okay, and then we will go back to the product, x sub 1 multiplied by x sub 2. Then we have negative b plus the square root of b squared minus 4ac. And then we have multiplied by negative b minus square root of b squared minus 4ac divided by 2a. As you've seen here, this is the sum and difference of two binomials. Okay, two terms. So we have negative b squared minus square root of b squared minus 4ac squared divided by 2a. And then this one is b squared minus, that will take the square root, so we have b squared, and then negative negative, it will give us positive 4ac divided by 2a. This will be 0. So now we can see that the product will be a. So we have 2c. It is always 2c. b squared, and then 4ac divided by 2a. No, it is 4a squared. Sorry for that. Because I did a terrible wrong here again. This one will be 2a, and this one will be 2a. So we have 4a there, a squared. So we have 4a squared. So that one will be 1, but this one will be a. Then we have 4, 4. So we have, now, I hope you is still there. You are still there. I will write it better. This is 4ac, and this is 4a squared. So that means the 4 will be 1, and that will be 1, and that will be 1. So we have c divided by a. We're going back now to the example that we have done. So x sub 1 multiplied by x sub 2 is equal to c divided by a. What is our c? That is 15 divided by a, which is 4. So 15 divided by 4. Then I have also 3.75. So the same. So you don't need to do this thing that I've done, this one. You just, if you add, you just divide b and by a, but it should be negative. And if you multiply, you want the product, it is always c, the last term, the constant term, divided by the numerical coefficient of the first term. What happened in our first example is that if we have x sub 1 plus x sub 2, it should be negative b divided by a. That is negative b, which is negative 5, divided by a, which is 1. We get positive 5, as you can see there. And x sub 1 multiplied by x sub 2 is equal to c divided by a. c is 6 divided by 1, and we have 6. And we get the same. I hope that you learned something from this video lecture. The next lecture or the next video that I'm going to do is equations transformable into quadratic equations, rational algebraic equations. Then it should be in the same topic. Yeah, see you there. See you next time.